continue our discussion on the survey network interface of our survey equipment on our small board. Now we shall discuss about the managed switches. Basically, there are two types of switches. One are the unmanaged switches, which earlier were used on survey spread. Even there would be survey spreads which use unmanaged switches, or the simple switches which we use in our home, but on our board we used a managed switch. To understand about these managed and unmanaged switches, we can use the OSI model or Open System Interconnect model, which basically divides the whole process of data getting created or generated in an application to the data being transmitted from a computer in 7 parts or 7 layers. These layers include the layer 1 physical layer, the layer 2 data link layer, 3 network layer, 4 transport layer, 5 the session layer, 6 the presentation layer, and 7 the application layer. Any data which is created or generated on any application on a computer goes through these 7 steps or 7 layers before getting transmitted out of the computer, and likewise it's inverse with the data getting received on a computer and opened in application. This OSI model and also the TCP/IP model is relevant to understand all the protocols, software and hardware that work for us to generate, process and transmit the data we are hoping to send or receive. Now on this OSI model, an unmanaged switch is just a layer 2 media access device, while a managed switch may work on a higher layer. Managed switch, apart from connecting the various computers on a local area network, can also provide network access control or ACLs, access control list. It will only send data to the computers it has on its access control list, which the IT administrator overlooks. IT administrator can edit and control. A managed switch can also incorporate the various other networking protocol, for example the RSTP, the Rapid Spanning Tree Protocol, and the vLans or the virtual LANs. What is this Rapid Spanning Tree Protocol? When we connect two communication devices, let's say two switches or a switch and a router, or a firewall on our LAN to a firewall on our server, we want to have redundancy, which basically means we want to have one spare cable connected between the two in case the first cable fails. However, the problem here is the data getting transmitted from a firewall or a system to the other would then loop around, and the data will keep going to and fro the two systems. That can just get the whole system down, take down the whole bandwidth of the system. We do not want it, and thus this protocol, which helps us to deal with the spanning tree of the data across the devices. And VLANs basically are virtual LANs or local area network. To put in perspective, let's say we have a project vLAN where the systems and computers are interconnected together to share data and store it. Then we have a processing department which want to get access to that data and process it. We can have other departments like a management department in an organization, the HR department. We do not want the data from one department to freely be accessed by any other department. But at the same time, in the same office building, we do not want to run too many cables or switches. So in this case, let's say on a 24 port S switch, we can allocate 1 to 8 ports to the project, then 9 to 16 port to the management, and 70 to 24 port to the HR. And thus all the computers in the vicinity are just connected to one switch, but they cannot get access to each other data because we divide the ports on the switch as virtual LANs or local area networks. While on an unmanaged switch, if it is a 12 port or a 24 switches, all these switches are just one local area network or just one LAN. I trust it is simple and easy. So I hope we get it. Managed switches just help us have more than one local area networks on a single switch by creating virtual LANs.